So for these 40 data points, summarize the scatter plot, then find the regression line. So presumably these 40 data points are in the Excel file. And remember how to summarize a scatter plot? We're going to be doing that. So go ahead and bring up that Excel file and click on example 3, that tab right at the bottom. So this data looks sort of familiar to us, but now they're giving us different labels for these variables. So here it says student-faculty ratio on the x-axis and cost per unit on the y-axis. So I'm presuming that each of these cases are something like schools, maybe universities. So when the student-faculty ratio is very high, then it's cheap to enroll at that school. It's cheap to take units there. But when the student-faculty ratio is very low, then it's more expensive, right? So that's what this sort of looks like. So number one, what are our cases? Our cases are probably something like schools or universities. Our variables are the student-faculty ratio and cost per unit. Number two, in summarizing the scatter plot, it seems as though the general shape of it is roughly linear, right? Roughly. So we can just stick with that. Number three, the trend seems to be a negative trend, where as one goes up, as ratio goes up, cost goes down. As ratio goes down, cost goes up, right? Number four, what does the sort of strength look like? Well, it looks sort of like maybe small to medium. That's sort of harder to eyeball. And number five, potential explanations. Well, it might be that in order to provide more faculty per student, a better student-faculty ratio, you need more faculty or you need less students, right? And so more faculty costs more money, less students, it costs more for each student to go. So that sort of makes sense. But it could be that when you have a high cost, you want to keep the student-faculty ratio low, or maybe it's some other third variable like prestige that keeps this relationship going. All right, so we've summarized the scatter plot, but I think now we have to find the regression line. In order to find the regression line, we don't really need this chart very much. So I'm just going to make it real small and put it over here. It's useful to look at later, just to eyeball whether our regression line sort of makes sense. But let's go ahead and take our steps to find Carl Gauss's method of finding B sub 1. So I'm going to write here x deviations, y deviations, x deviations times y deviations, and then x deviations squared. And this is when Excel comes in real handy, because it would be really sort of crazy in order to do all of these, right? And just to make life easier for us, let's go ahead and find x bar and y bar right here. It doesn't really matter where you find this, just somewhere easy for you to keep track of. So I'm going to find the average of all my x's, and I'm just going to use student-faculty ratio as my x's. So the average student-faculty ratio is about 20 students per faculty. And I'm just going to copy that over, and the average cost is about $366.60 per unit. All right, and now let's find the x deviations. So that would be my x's minus x bar. And I want that to just stay locked in place. And then I'm also going to find my y deviations. So y minus y bar. And I'm going to lock that in place. And then I'm going to multiply my x deviation and y deviations together. And I'm also going to find x deviations squared. Right? Once I have this, I could actually just copy and paste all 4 of these values all the way down for all 40 data points. And if you take a look, half of the x deviations should be negative, and approximately half are positive. And same with the y deviations. Some are positive, and then some are negative to balance that out. All right. So now we know we need to find the sum. So we need to find the sum of our x deviations times y deviations. And just to help us out, I'm just going to pull down this little bar right here. If you see in the corner, there's this little sort of sandwichy looking thing. I pull that down in order to lock that row in place so that that row doesn't move. And then I can move that down, and I know what column I'm in. So I want to sum all of these. Oops. So I'm going to sum all of these together. And then I'm also going to sum all of these together. And I'm just going to color all of this in a different color so we know. And now let's find b sub 1. Now b sub 1 is this ratio, the ratio of this sum over this sum. And so our slope is a negative slope, and that makes sense because we had a negative trend, and that's negative 21.51. And given that, let's find b sub 0. And we know in order to find b sub 0, we're going to need to use x bar and y bar as our example point. So I'm going to take my y. I just wanted one of them. Let's see if that's the right one. Okay. My y minus b sub 1 times x. And I get a y-intercept of 795.21. All right. So I'm just going to pull this over on the side. And here, I can now talk about the regression line. So the regression line would be y equals, and we put the intercept first, 795.21. Instead of plus, we could just put a minus, because our slope is negative, 21.51 times x. So this is our regression line. And if you want to interpret it, the idea is that sort of the base cost is around $800. And for whatever the student-faculty ratio is, with each increment, you get sort of a deduction of about $21.50, right? So as the ratio goes up and up and up, you get a little deduction every time. All right.